Guys, in this video I'm going to show you how to solve frequency stack problem. So design a class that simulates a stack data structure implementing the following two operations. Push takes in a num, pushes the num on the stack. Pop return the most frequent num in the stack. If there is a tie, return the number which was pushed later. Okay, let's see. So let's run to this example, right? So let's uh, do a little bit of visualization here. Okay, anyway, this one should be better. Okay, so first thing I will push 1 to our stack. Okay, I push 2 and 3. Okay, again I push 2, then I put 1, push 2. Now here, okay, another, no, 1, we have only 2, right? 2, and then we put 5, so 5, 7, okay, we have 7 pushes here, and then want to pop. So unlike in normal stack, the pop operations should return the number with high frequency, right? That is most frequent right now, and this right now, as you can see here, 2 is the most frequent number we have right now. So the first pop would return 2, right? The second pop, so we lost 1 2 here. Okay, anyway, let's okay, the second pop here, this is the case when, let's come back, this is the case when there's a tie, return number which was pushed later. So we have 2 number here, which is 1 and 2, that has same frequency, right? So in this case, let's see here what would push later. So as you can see here, this is the third 2 which was crossed. We has removed it, and we just go back one step, it's 1. So actually this one is was pushed later, so this pop should return 1 instead. So remove it, and the next pop here should return 2, because here 2 is a dominant, right? 2 is dominant right now. Okay, so this should return 2. So anyway, as you can see, essentially what we have to do here is to just return the number that has the largest frequency right now. So this leads us to a data structure that is optimized for these operations, which is a heap, right? And typically a mux heap, So okay, let's uh, let's see how to use the mux heap to solve this problem. Okay, let's say here is a mux heap, right? Here is my mux heap. Mux heap. So okay, what wanna push in the mux heap? Just gonna push the only the number? Probably not. Uh, because we want to extract at any time extract the number with high frequency. So probably I'm thinking that when I use a an item that I push in here could be like this. Like for example, on the first step, it would be 1, right? Is a number itself and the frequency is 1, right? Okay. And the next, and when I instruct Moxie to use the second argument, no, second element to extract the largest value. The next one is push 2. Okay, 2 at this point is 1, right? Next is push 3. 3 at this point is 1. Next is push 2. But as you can see, except for the mux heap, we need another data structure to store the the current the current frequency of a number, right? Even though we store um, 2 with frequency 1 here in the mux heaps, but there's no way this mux heap will for the mux heap we do not have access to um, we do not have access to every element, right? It's not used for that purpose. So it means that we need to store uh, our number along with current frequency, right, in the data structure. So it should, you may think of it, and it's is the what color? Okay, it is uh, it's just simply a map, right? That map a number with the frequency right now. So currently I have 1, 1, 2, 1, 3, 1. Okay, so we are here right now. So when I push 2, so we can look here to find the number 2. Yes, we do have 1, 2 here that have frequency 1, right? So means I can add the next item 2 and the new frequency. Sorry, here I should update this, and now it's 2 instead. And now I will push new item to the market, which is 2 with the new um, frequency. As you can see, we're storing all the instance up to, right? But it is different frequency here. Okay, so next would be push 1. So I do have number 1 here, so I will update it to 2. So it means I need 1 and 2, right? Next will be push 2. I have 2 number 2 right now, so I will update to 3. Okay, next push 5. I do not have 5 here, so I will add a new record with frequency of 1, and then I push 5 in here with frequency of 1. Uh, now we're done. We're done pushing. So the great thing of the Maxip is that it will always know that which is, oh no, maybe I missed something here. Two, we miss this 2, right? So we should have 2 with frequency of 3 here. Okay. Again, the great thing about Maxip is that it always know which item in here has the largest frequency, and it can instantly extract this. So the first part, we can take this one out, right? And the second part, it will instantly find the next largest frequency. But as you can see in this case, it see 2 items with largest frequency, which is 2, right? So we must handle this guy, right? And as you can see here, we should return the number which was pushed later, and in this case it should be 1, this item. But how do we instruct the Maxip to be able to recognize this should be the one that is going to be out? So as you can see, you might notice that as we just like keep every instances, um, every push here, after every push here we have a different instances, we have different instance inside the Maxip, right? So like for example, even with 2 here we have 3 different instances, 2 with frequency 1, 2 with frequency 2, 2 with frequency 3, right? So it means that um, because we're adding like everything, we just keep every push step here in the Maxip. So one way to just keep another variable in this um, in the item, right, which indicates the order that it would push in the Maxip. For example, um, for the first push, it is 1 1 here. I could, let's say, my first count is, let's say, 0. Right? Next push 2, so it should be this one. So my count now will be 1. Push 3, so my count here should be 2. Push 2, it is this guy. So as you can see, 0, 1, 2, 3 now. And next, push 1, it is 1, is 4. Push 2, this should be 5. And push 5 should be 6. Okay, so so when we come to this part, we currently have two items with same frequency, 2 here. So in this case, we're going to rely on the third uh, element here, which indicate which will push later. In this case, 4 is greater than 3, so it means this item will push later, right? Okay, so we handle all the cases for this problem. Let's run. Okay, for this problem, gonna take out this one, and the next part, which has the largest frequency right now, it is this item, right? Because it has frequency of 2, largest, then everyone else is just 1. So next one now is 2. Okay, so that is it. Let's turn everything into code now. Okay, so I need a heat, right? I need a map, frequency map, right? That keep track of number and each frequency. And the second thing, no, it should be this instead. This dot what max heap, let's say. So new heap. Initially it's just an empty, and the third argument will determine whether it is a max heap or min heap. So want to decide the form of an item inside the heap, and the first element of item is just an array, which first element is a num, the second element is a number frequency, and the third um, element is let's say the order, right? So when to instruct the max heap how to find the item with largest frequency, right? So you may think that we can do like a at index 1 minus b at index 1, but this only handle the case when the number frequency is different. So it is when a one equal to b1. No, it's different. When a1 is different, then we're gonna use a1 minus b1. But if a1 equal to b1, then I'm gonna use the third element to determine which should be out, the next to be out. So because I favor the one with high order, right? So a2 minus b2, and we'll also need to keep track of the order. Initially it's 0. So push number, firstly I'm gonna update it in the frequency map here. So if the number not in the frequency, then I'm gonna initialize it with initialize to 0. And prior to that, I'm gonna update it frequency by 1. And then what else should I do? I need to add it to the max heap. Sorry. The item will be informed on array, and the first element is a number, right? The second element is its frequency, so I can take out from the frequency map. And the third should be the order, the current order, right? So after, so for every push, wanna use the current order, and after that I'm gonna increment this order by 1, right? So I wanna keep track of what will push later. The item with high order should be the one that we push later. Okay, what else? For the pop, I just simply uh, use the, I'm gonna just take out one item from the mux heap, right? The mux heap will handle everything for us. So the item that is out will be in form of an array. We need, what we need here is just the number itself, which is at index 0. Okay, I think we're done with it. Let's run a test. Okay, so I think that is it for this program, and thanks for watching. See you in the next video.